Okay, this is 12.3 distribution of data. April 3rd, 139 is your page number. So hopefully this will help you with this. Is going to be hard. There's 3 problems I'm going to do on the TI-84 graphing calculator. So a distribution is a set of data that shows the observed or theoretical frequency of each possible data value. Recall that a histogram is a bar graph used to display data that have been organized into equal intervals. A histogram is useful when reviewing the overall distribution of data within a set range. Okay, so you can see the shape of distributions by drawing a curve over the histogram. So negatively skewed data is the majority of the data is to the right, and it's called skewed left. It has a tail to the left, so skewed left. Symmetric data, the data are evenly distributed, and then positively skewed data is skewed to the right, meaning a tail to the right. Majority of the data is to the left here, as you can see. So I'm going to give you one first example. Now, the first example, it says use a graphing calculator. So you're going to have to find some kind of calculator, or you're going to have to do this histogram on a piece of paper, but you got to take all these values. That's what you're going to have to do on 4, 5, and 6 of your work. So what I did is I put all of these in list 1. So list 1 is stat, enter. Remember stat right there, enter, and there's my list 1. So I got list 1, list 2, list 3 for example 1, example 2, example 3 on this page that we're going to do. So all my numbers here are in list 1. From there, I press stat plot because I got to turn a stat plot on. Stat plot's in blue, so second stat plot, I need to turn it on, and I'm going to make a histogram. So when I turn it on, right now it's at a box plot, and we'll talk about that in a little bit. So I want to make it a histogram. So I go down and to the right, and I go over the histogram, hit enter. Now I want list 1. See, right now it's list 2, so I need to go down to it, and I need to go second. List 1 is over the 1 key down at the bottom. You'll find it in blue. All right, so I turned on list 1. Now the thing about it is I got to find the highest and lowest. Now if you remember, if you hit stat, calculate, variety of stats is your 5-number summary. So hit enter. I want list 1. Again, I got to change this list 2 to list 1. So second list 1. And now I'm going to calculate the variety of stats. Remember, this is the mean, and this is the sum, this is the square, this is the standard deviation is 6.9 right there. So you can see, remember that symbol right there means standard deviation. All right, so if I go down to the 5-number summary, my minimum is 18, my maximum is 43. There's my Q1, Q2, Q3, medians, Q2. And I could make a box plot based on that data. So once I put it in the calculator, I can do a box plot. So what I'm looking for here, though, is to make a window. Window goes from 18 to 43. So I'm going to go from 0 to 50 by 5s. So to make my window, you have to make a window on this set of data. So I'm going to go window. I'm going 0 to 50 by 5s, and 0 to 10. What 0 to 10 is up and down, meaning how many values are between 0 and 5, between 5 and 10, 10 and 15, 15, 20, etc. So now when I hit graph, I see nothing. All right, so I need to go back to stat plot and make sure it's on. Make sure I have a list 1. So I do that. List 1 is a histogram. I got to turn it on, make sure it's on, and hit graph again. And why is my graph not there? Let's look again, my window. Window 0 to 5. Okay, there's my problem. It should be 50. Okay, there you go. So that should be 50 going by 5s. There's my mistake. And 0 to 10. And now when I hit graph, there's my graph. And that's why my 0 to 50. Actually, I'm glad I did that so you can figure out what I did wrong. So now what does that mean? Well, if I hit trace, now it doesn't look like this graph, and I'll tell you why. Because this graph starts at this number here. So if I hit trace and then I hit a right arrow key, it gives me my values between the intervals. Now I started at 0. They started at 15 here. Okay, this graph starts at 15. Now, why is my graph different? Because my intervals are different. This means minimum of 15, less than 20. So they have it where it's equal to 20. So this is going to be slightly different because the intervals are different. This bar means how many values are from 20, minimum of 20, less than 25. They have it equal to 25 on this one. So if you continue to move around, but it still has the same kind of curve. So it has a skewed to the right tendency, meaning all the values are more left, but the tail is to the right. As you learned up here, skewed right looks like this. This graph looks like this. So with that information, you can say the graph is high on the left and has a tail to the right. Therefore, the distribution is positively skewed, which looks like this. That's the positively skewed one. All right, if we're looking at a box and whiskers plot, so I'm going to change this in a minute, still the same values, to a box and whiskers. So how do I change that? Well, I go second stat plot, I go into my plotter, and I'm going to change this to a box plot. So I'm going to go over and down and keep moving around to this box plot. We're going to talk about this box plot in a minute. That's an outlier. So we're going to hit that box plot, hit enter, still list 1. And now when I hit graph, I have the graph there, which looks similar to this graph, except it's moved over. Well, it's going to be the same. If I hit trace, that gives me the minimum, 26. As you can see here, is 26. If I move left, that's 23. That's about 23, how they have it here in the graph. If I move left again, that is their minimum value, 18. So this is your 5-number summary. 18, move right, 23, 26 is Q2. So minimum, Q1, Q2, Q3 is 34, and maximum is 43. Now, what does this mean? A box and whisker can be used to identify the shape of the distribution. So in this example, I'm going to move this up slightly, move down here. And notice that the left whisker, right here, this left whisker, which is right here, is shorter than the right whisker. So that means that the line represent the median is closer to the left whisker. Okay, the line representing the median. See, the median here is closer to the left whisker. All right, this represents a peak on the left and a tail to the right. That's what that represents. When that's closer to the left whisker, it's a peak on the left and a tail to the right, which is exactly what we got here. Okay, so now I'm going to do example 2. So example 2, I'm going to go second, quit, and get it out of this. I'm going to come down to example 2. So I got to move my there we go. Move my camera down. This has list 2. I put all these in list 2. So if I go stat, enter, I have them all in list 2 right here, all these points. There's an outlier of 53, which I found. So when we hit the stat plot, now I got to change my stat plot to list 2. So second stat plot, I got to go into it. I got to go down to list 1, change to list 2. So second list 2, which is above the 2 on your calculator. All right, now when I show this one using this box plot, here's what it looks like. Okay, that's what it looks like. And it goes off the graph. So that one means there's some outlier out there. Well, when you look through the set of data, 53 is an outlier. So what you have to go do is go back to second stat plot, change your plotter to the first box plot, because that will give you your outlier. You'll see in a minute when I move it over to that. And if I choose that one, I'm still list 2, example 2, list 2, hit graph, and you can see that it gives you this. And then here's the problem. I'm not only going to 50. So I'm only going to 50 on that window. That's why it's not showing 53. So I need to change my window. So I go window, 0 to 50. So that point 53 is not going to show up. So I'm going to go to 60 and still go by 5s. Okay. Now when I hit graph, you can see the outliers right there. This is a symmetric graph other than that outlier. So if we didn't have that outlier in there, we'd have almost a symmetric graph. The lengths of the whiskers are approximately equal, and the median is in the middle of the data. This indicates that the data are equally distributed to the left and right of the median. Thus, the distribution is symmetric other than that outlier. And that's how you graph an outlier. An outlier is way out there. All right. So let's go to the next page, and then we'll talk about, I'm going to move this over here, and we're going to talk about this distribution. So let's see if that'll get clearer there, hopefully. All right, you have learned that the data can be described with the mean and median describe the center. So here's your mean, and in a symmetric graph, your mean and median are the same. The standard deviation and quartiles describe the spread, how spread out that is. So let me see if I can go a little closer and so you can see better. When a distribution is symmetric, the mean accurately reflects the center of the data. However, when the distribution is skewed, right or left, right or left over here, the statistic is not as reliable. That's what it means. So you discovered the outliers can have a strong effect on the mean, while the median is less affected. So when a distribution is skewed, the mean lies away from the majority of the data towards the tail. The median is less affected and stays near the majority of the data. So when it's skewed left, the mean is to the left. So anything that's skewed left, as you can see, I'm going to try to get these both in a picture. Let me move back out. So when it's skewed left, the mean is to the left of the median. When a distribution is skewed right, the mean is to the right on the median. Just remember that. All right, if the distribution is relatively symmetric, let me move in a little bit more again. If the distribution is relatively symmetric, the mean and standard deviation can be looked at. If the distribution is skewed or has outliers, use the 5-number summary. So that's the difference of when you're talking about different things. All right, let's do example 3, and hopefully I can get this in the picture. So I'm going to move out a little bit so I can get my calculator in this one. This is example 3. So this is list 3. I put this in list 3. So if I go stat, enter, I have all of these points in list 3. So I have to do everything in list 3. So if I want to make a histogram, then I go second stat plot, enter, go down into the histogram, hit enter. Now my histogram, I got to figure out is my window. So I'm going to just guess that my window's right. So I'm going to just hit graph from the other two. But I don't have list 3 here. So I got to go down to list 3 and hit second 3. Second 3 is list 3. It's in blue. Hit graph, and my graph is in here. Looks the same. It looks good. Got everything in there, so I don't need to change my window. The graph is high in the middle, so see how it's high in the middle, and low on the left and right. Therefore, the distribution is symmetric. Now, why is this different than this? It depends on how the graphing calculator does it a little bit different than what they have on here. So there's more here, but you still get the same tendency. All right, so if I hit trace, you're going to see between 0 and 5, you have nothing, and then you keep moving up, and between, including 15, less than 20, there are 6 data points, where here there isn't 6 in this one, okay, in this first one, because they have it distributed differently. All right, this distribution is symmetric, so use the mean and the standard deviation to describe the center. So I want to go to the variety of stats to describe this. How? Stat, okay, stat, if you remember, calculate, okay, and then variety of stats, the first one, and then we need list 3, so L, second, list 3, and then calculate, enter. And here's my variety of stats. Here's the mean, 26.08. You can see it's exactly that same thing. Standard deviation right here, 7.1. Okay, so standard deviation, remember that means standard deviation right there. That symbol right there means standard deviation. And okay, so the mean is 26.1 and standard deviation is 7.1, and we're done with describing and putting it in the calculator. All right, lastly, last things you need to know, symmetric and skewed box and whiskers plots. If it's negatively skewed, meaning it's skewed to the left, then you're going to have the left whisker is longer than the right. The left whisker here is longer than the right. The median is closer to the shorter whisker. If the whiskers are the same, the median is in the center of the data. So here's your median right in the center. And if it's skewed, positively skewed, all right, then it's skewed to the right. The right whisker is longer than the left whisker. Right whisker longer than the lesser. The median is still closer to the shorter whisker. And that's all you need for today.